Welcome to this video. Here we'll be continuing this 1969 AP Calc AB multiple choice questions. We left off on number 16. Okay, so I'm going to solve the next, I don't know how many problems, whatever I can do in about half an hour. Okay, so we might have a part 3. So number 16 says if y is a function of x such that y prime is positive for all x and y double prime is negative for all x, which the following could be part of the graph of y is f of x. So this should signal the f is a y is increasing because the derivative is positive. This should signal y is concave down because second derivative is negative. So what is increasing but concave down? This is increasing concave up, increasing concave down, decreasing concave down. This is what? This is concave. This changes concavity actually, and this again changes concavity too. So 16 is B. Graph of y is 5x to the fourth minus x to the fifth. Has an inflection point at where? Okay, so I'm going to use the space up here. Inflection point, that should signal second derivative. So y prime, first of all, would be what? 20x cubed minus 5x to the fourth. Okay? Y double prime would be what? 60x squared minus 20x cubed. We set this equal to 0 to find the critical points, okay? So if we factor out 20x squared, we would get what? We get 3, right? 3 minus x. So our critical points are x is 0 and 3. Okay, so let's do the second derivative test. So we plug in some points less than 0. What's the sign of y double prime? If you plug in a huge negative number, well, something squared is always positive. Plug in a huge negative number, this would be positive, so sign there is positive. We plug in a number between 0 and 3, like 1, positive. This is, again, positive, okay? And then we plug in a huge positive number, like 1,000. This is always positive. This would become negative. So the derivative is, second derivative, the sign of the second derivative is negative. The second derivative only changes sign at x is 3, so that's the only point of inflection. So it should be B. Okay. F of x is 2, absolute value x minus 3 for all x. And the value of the derivative f prime at x is equal to 3 is what? Okay. So the confusing part here is probably this absolute value. Okay. And it's actually that makes this non-existent, because remember the derivative does not exist when there's a sharp turn, because remember how absolute value looks like the v at this point there is the what's the slope of the tangent line there? Is it the negative or the positive? So that's why it's non-existent. This is the absolute value shifted by 3 to the right, if I remember correctly, and up by 2, so it still has this shape. So f prime with 3 is non-existent, does not exist. Point moves on the x-axis in such a way that its velocity is given by this guy. At what value of t does v attain its maximum? So to maximize v, we want to differentiate it. So we want v prime, which is actually the acceleration. Okay, how do we do that? How do we find v prime? Well, actually we can rewrite v as what? ln t times t to negative 1, if that makes your life easier to do product rule instead. So if we do the product rule, it'll be first d second plus second d first. So first d second derivative of t to negative 1 would be negative 1 over t squared, okay? Plus second d first would be another t to negative 1. Derivative ln is 1 over t, right? Or t to negative 1. So we can rewrite v prime as negative ln t over t squared plus 1 over t squared. V prime is 1 minus ln t over t squared. Okay? So we set this equal to 0. Okay, so 1 is the numerator equal to 0. So 1 minus ln t is equal to 0, or 1 is ln t. When does that happen? When t is equal to e. Okay, so it's likely that it's c, but let's confirm. What's the sign of v prime when t is less than e? For example, if it's 1, okay, it cannot be 0 because we divide by 0 here. If it's 1, then ln of 1 is 0, right? So it'll be 1 over 1 squared, so it's positive. If we plug in a huge positive number, then it would be 1 minus the huge positive numbers, that's be negative, over some positive number squared is positive, so it'll be negative. So we confirmed it's a max at t is e. Okay. We did the first derivative test on v, basically. Okay. Let's move on. Equation for a tangent to the graph of y is arc sine of x over 2 at the origin is what? Okay, so let's find y prime first. I don't know if there's enough space there. Y prime, what's the derivative of arc sine? 1 minus the argument, which is x over 2. Then we need to chain rule, times derivative of x over 2 is just half, okay? So we want the slope of the tangent line at the origin, so that's when x is equal to 0, okay? So, okay, let me block this off. What's y prime equal to when x is 0? So this is just half, it looks like, right? So when we have a slope, we have a point, because the origin is 0, 0. So it'll be y minus 0, the point slope form, is equal to half times x minus 0, or half x. Y is equal to half x. We don't quite get one of those. We need to reorganize it a little bit. It would be, looks like it's a, though. Yes. Okay, if you just rearrange the sky over here a little bit, or even rearrange the sky, so it'll be negative 2y is equal to negative x. So y is equal to x over 2, which is the same thing here. Okay. At x is 0, which of the following is true of the function f defined by this guy? Okay. This is asking about increasing, decreasing, discontinuous, relative max, min. So just by the first two and the last two, probably want to differentiate, okay? How about when x is 0? Is it discontinuous? At x is 0? No, it's continuous everywhere because x squared is continuous everywhere. E to x is continuous everywhere also. Okay, so clearly it's not C. Okay, eliminate that. Okay, so let's find f prime. F prime is equal to 2x minus, we need to chain rule here, it'll be minus 2e to the minus 2x, okay? So let's set this equal to 0. Let's do the first derivative test. Okay, so does this have any solution actually? Actually, it's talking about at x is 0. So we don't need to do that. Well, maybe we need to do that here, okay? At x is 0, what's the value of this? So f prime of 0 would be 2 times 0 minus 2e to the 0. So this is 0 minus 2 times 1, which is negative 2. It's not equal to 0, so it cannot be a maximum min, right? And then it's negative, so it's decreasing. So 1's B. Okay, that's how we do that. This guy, oh, this is very easy. You could just blindly do it, and you'll realize that it's the, you could do the chain rule, that's fine. Or you realize you could simplify this as the derivative of 2x. Okay, by properties of logs, because there's a log, there's an e, they would cancel each other out. So this is just what, 2. And 2 is e. Simple as that. If you didn't recognize that, you could just simply use the chain rule also. It'll be fine. area of the region bounded by the curve y is e to 2x, the x-axis, the y-axis, and the line x is equal to what? Okay, let's sketch this region real quick. E to the 2x, just a sketch, looks something like that. Okay? X-axis, y-axis, line is x is equal to 2. So if 2 is out here, okay, then this is the region here. Okay? It's talking about area. So we're going to just integrate from 0 to 2. This is e to 2x, right? It'll be integral from 0 to 2, e to 2x dx, because integral is area under the curve. It's the area under e to 2x from 0 to 2. Okay? This is just what? Half e to 2x. Evaluate from 0 to 2, which is half times e to the 4th minus e to the 0, which is half e to the 4th minus 1. Half e to the 4th minus 1. Looks like it's C, yes. Okay. If sine x is e to the y, given this interval of x from 0 to pi, what is dy dx in terms of x? Okay, so let's just differentiate this, probably implicitly differentiate. So actually I could probably squeeze it here if I do it correct in one shot. Derivative of sine is cosine. Derivative of e to the y is just e to the y, dy dx. Okay, so dy dx, if we solve for it, it's just cosine x over e to the y. Okay, e to the y is just sine x, so it's cosine x over sine x. What is this? This is cotangent x. So 24 is C, as simple as that. Okay. Region in the plane bounded by the graph of y is 1 over x, the x-axis, and the line x is equal to m, and the line x is equal to 2m. M is greater than 0. The area of the region. Okay, so there's this region bounded by graph of y is 1 over x. How does that look? 1 over x looks something like this. Okay? The x-axis, the line x is equal to m. The line x is equal to 2m. M is greater than 0. So it's going to be in the positive x. Okay? So some line here, m to m. Okay? Like so that's the thing. The area of this region is independent of m, increases as m increases, decreases as m increases, blah, blah, blah. Okay? So let's try to figure out what's going on. Okay? So the area of this region, we can even just put it in an integral. From m to 2m of, what was it? It was 1 over x dx. Okay? Okay, so actually let's maybe try to solve this first, or get a little further. If we do fundamental theorem, if we integrate, find the antiderivative, that's just log of x, evaluate from m to 2m, which is ln of 2m minus ln of m. Okay? Or we could write this as ln of 2m over m. Properties of logs, this is just ln 2. Okay? So actually, the area does not depend on m. 25 is A, actually. That's kind of interesting, actually. Once again, they're talking about area, so that's just signal integral. It's actually the integral from m to 2m, 1 over x dx. So that's what we did here. We just started simplifying or solving. So that ln x from m to 2m. We do fundamental theorem of calculus, that's ln of 2m minus ln of m. Properties of logs, we can combine these into one fraction, 2m over m. And the m's get to cancel, and we get ln 2. Okay, so the area, which is always ln 2, So that's independent of n. Okay? How about this one? Integral from 0 to 1, square root of x squared minus 2x plus 1 dx is what? Okay? So here you got to be a little careful probably because, well, we can factor the inside to x minus 1 quantity squared. Okay? But when we square root this, you got to be careful. Okay? So we would write it as, because it'll be plus or minus x minus 1. So we can write it as integral from 0 to 1, absolute value x minus 1 dx. Okay? So once again, when we square root, it should be plus or minus x minus 1. So another way to write it is absolute value of x minus 1, okay? For this case. Now, here, since we're integrating from 0 to 1, we're on the negative side. Remember, absolute value x looks like this. This is absolute value x minus 1, something like that. So from 0 to 1, we're on this negative side. So it should be integral from 0 to 1, negative of x minus 1 dx, or just 1 minus x, right? So that's integral from 0 to 1, 1 minus x dx, which is just x minus x squared over 2, evaluate from 0 to 1, which is just 1 minus half, which is half. That's x is c. Okay, that's how we solve that. If dy dx is tangent x, then y is equal to what? Okay, so if you remember what the antiderivative of tangent is, it's just ln of secant x plus c. Okay, if you don't remember it, you can, y is just the integral of tangent x dx, which you can write as sine x over cosine x dx. And you could do a substitution where u is cosine x, du is minus sine x dx. So your integral, I'll continue over here, becomes minus du over u, which is minus log of u plus c, which is minus log, what's u? Cosine x plus c. But it doesn't look like ln secant y. Well, we can bring this power back in, so it'll be log of cosine x to the negative 1 power plus c. This is the same thing as secant x, because 1 over cosine is secant, so same thing there. Okay. Function defined by f of x is root 3 cosine x plus 3 sine x has amplitude of what? Okay. This one, I'm thinking there's probably multiple ways to do this. Like if you know, the problem is sine and cosine are shifted, right? Cosine is shifted by pi over 2 with respect to sine, and we say cosine is earlier by pi over 2 actually. So if you can figure out from that, after like all the shifting and stuff, where the maximum value is, then that works. Well, another way is, let's find a derivative. Amplitude is either the maximum or the minimum value, right? So let's find a derivative. So f prime would be what? Minus root 3 sine x plus 3 cosine x. Let's set it equal to 0. Okay? So we would get what? 3 cosine x is root 3 sine x. So 3 over root 3 is tangent x. Okay? Or tangent x is root 3 over 3. Do we know when that happens? When x is equal to which one? I believe that one is, okay, so root 3 of 3 is the same thing as 1 over root 3. So if x is pi over 3, sine is 1 root 3 over 2, right? Sine is root 3 over 2. Cosine is half. So root 3 over 2 divided by half. Yes. Is that right? Sine pi over 3. Root 3 over 2. Or actually, I did something wrong here. So it'll be tangent x 3 over root 3, which is 3 root 3 over root 3 times root 3, which is, what, 3 root 3 over 3, which is root 3. There we go. I'm like, something didn't seem right. Okay, so tangent x is root 3. Where is that? That is when x is pi over 3. So we plug x's pi over 3 back here. So f of pi over 3 is what? That would be root 3 times cosine of pi over 3 is what? Half. Okay, plus 3 sine of pi over 3 is root 3 over 2, which is what? This is root 3 over 2 plus 3 root 3 over 2. So that's 4 root 3 over 2, which is just 2 root 3. 28C? Yes, it is. Okay, there we go. Hopefully that made sense. So one more time. The way I approached it was, well, amplitude, we know that's the max or min value of f. We know this is periodic. So let's find the derivative. So f prime, we found the derivative. We set it equal to 0. We solve for the critical point. That's x is pi over 3. We plug pi over 3 back into f to find the amplitude. Okay. This one, I think this page would be, actually, how many pages do I have left? We'll see how I go. I might stop after this page for this part of the video. Okay, so this one, how do we solve this integral? Well, if you remember the integral of cotangent, because that's what this is, right? Cotangent x dx. Great, just use it. I'm just going to do it the long way. If we let u be sine x, du would be cosine x dx. So the integral becomes, we have to change the limits of integration. When x is pi over 4, u is root 2 over 2. When x is pi over 2, u is 1. Okay, so it'll be du over u, which is log of u, evaluate from root 2 over 2 to 1, which is ln1, which is 0, minus log of root 2 over 2. Okay. So this is what? This is the same thing as root 2 over 2 is the same thing as 1 over root 2, which is root 2 to the negative 1 power. So this is bring that power out, so it'll be log of root 2. 29 is A, yes. If a function f is continuous for all x, and if f has a relative max at minus 1, 4, and a relative min at 3, minus 2, which of the following statements must be true? Okay, let's go one by one. Graph of f has an inflection point somewhere between negative 1 and 3. If this has a relative max, and relative max at negative 1, and a min at 3, that means it'll look something like the point of inflection somewhere between relative max minus 1, 4, or actually I can even sketch it real quick. Minus 1, 4, let's say it's up here. 3 minus 2. Point of inflection doesn't need to have a point of inflection, because if it's relative max, relative min. If it's a piecewise type of function, then it might not have a point of inflection. So let's keep that in the back first. Let's not eliminate it completely. How about f prime of -1 is equal to 0? Does that have to be true? You're tempted to say that because relative max, you immediately think, oh, slope of the tangent line has to be 0. But if it's like the absolute value x, that type of piecewise, if it's like a linear curve here and then a linear curve there, again, it's possible because it just says it's continuous. It doesn't say it's differentiable. That's the key, actually. Relative max min doesn't necessarily have to be differentiable there. So this we know is not necessarily true because we don't know if it's differentiable there. So let's cross that out. Graph of f has a horizontal asymptote. I don't know how you would get that information from just knowing that there's a relative max there and a relative min there. Cross that out. Horizontal tangent line at x is equal to 3. Again, we don't know how it looks before and after, if it's even differentiable there. Okay, so D is not true. Okay, how about, so we're left with A and E. What's E? The graph of f intersects both axes. This is probably talking about intermediate value theorem, okay? Because one point is positive, one point is negative. There has to be a point such that it crosses the x-axis. So that's that axis. How about the y-axis? Well, it's continuous for all x, so it has to cross the y-axis. So this has to be true. There we go, okay? So we went each choice and we found out E has to be true. So once again, the key here was we don't know if it's differentiable. So it eliminated a lot of the choices actually, okay? So specifically the counterexample is if it was like piecewise, continuous, okay? 31, if f prime x is negative f of x and f of 1 is 1, then f of x is equal to what? Okay, so honestly, I would just start looking at the choices to see if f prime x is negative f of x, okay? If we differentiate e to the x, it's just e to x, but I mean negative e to x, we get negative e to x, so f prime is f, so no. This would possibly be true, this for this condition. If we differentiate e to negative x, we would get negative e to negative x. This one, you would get, if we differentiate this, you get negative e to the 1 minus x, so we can hold that off. This one, you get, again, negative e to negative x minus 1, so we can keep that. This one, you get what? You would get half times negative 2, which is negative 1, e to the minus 2x plus 2, which is not that. So you eliminate 2 of the choices already. Now, f of 1 is 1. Let's just see if that's the case. If x is 1, then the y value is e to negative 1, which is not 1. If x is 1, e to 0 is 1, so we keep that. If x is 1, e to negative 2 is the y value. Again, not that, so choice C. As simple as that. Didn't have to do anything real fancy. Okay, if a, b, c, d, e are real numbers and a is not equal to 0, then the polynomial equation this guy has, talks about roots. Okay, so they're all real numbers. So how does this have to do with roots? So immediately I think that since since it's to the 7th power, there could be up to 7 real roots. 7 roots. Okay. Yeah, 7 roots. Real or imaginary. Okay. First of all, this says an odd number of non-real roots. Non-real roots, they always come in pairs. So this C cannot be true already for that. Okay? Only one real root that cannot be, it could be true, but not necessarily true. At least one real root. I think this is a choice because I just said if there are any non-real root, it has to be even number of, okay, so non-real roots, they come in pairs. That's probably the key here, okay? So if there's 6 non-real roots, there's 1 real root left, okay? So that's possibly true. So we eliminate A. No real roots, we just said they have to come in pairs or even numbers, so 7, the nearest even number is 6, and then we need at least 1 real root then, so that's not true. No positive real roots. It can have a positive real root or a negative real root. We don't know. It has to have at least 1 real root, so 32 is B. Okay. What is the average mean value of 3t cubed minus t squared in this interval? Okay, so this will be the last problem for this part. Average value, that's very easy. That's 1 over 2 minus negative 1. Integrate from negative 1 to 2, 3t cubed minus t squared dt. Okay, so this is what? 1/3 integral from minus 1 to 2, 3t cubed minus t squared dt. You just use the power rule, so it would be what? 3/4 t to the 4th minus 1/3 t cubed. We evaluate from negative 1 to 2. Okay? So we just solve, then we would get what? 2 to the 4th is 16. 16 divided by 4 is 4. 4 times 3 is 12. Minus 2 cubed is 8, so 8/3. And then minus, we plug in negative 1, we get 3/4. We plug in negative 1, we get plus 1/3. Okay? So we would get 1/3 times, what is this? 12 minus 3/4 minus 8/3 plus 1/3, that's minus 7/3. Okay? So we get 4 minus 1/4 minus 7 over 9. Did I do this right? Do I have some math error somewhere? 1/3, 3t, 4. This is correct, so did I do something wrong here? Minus 3/4. Oh, okay, sorry. Minus 1/3 and minus 8/3, that's minus 9/3. Okay, so I did do something wrong there, sorry. So this is what? 9 divided by 3 is 3. 12 minus 3 is 9. So we get 1/3, 9 minus 3/4, which is 3 minus 1/4. So 2.75, which looks like A. Okay? Okay, sorry for that small mistake at the end. Okay, so we'll call it another part here. So hopefully this was helpful. Please like this video if you found it to be helpful. And please subscribe to the channel to look out for the third part.